welcome to the Maritime Vision podcast. I'm your host, Paul Wioli. In each episode, we bring you exclusive interviews with maritime professionals, industry experts, and students. Our guests come from different backgrounds, including shipping, yachting, offshore, supply chain, and more. Our goal is to give you all the knowledge you need to succeed in the maritime industry.
Hello everyone, welcome back to a new podcast episode. And today we are with Hans van Loon. He's a project engineer and naval architect. So Hans, it's a pleasure to having you in this podcast episode. Can you introduce yourself, please?
Yeah, nice to be here. I'm, as you say, Hans van Loon, Dutch born and raised. I studied naval architecture in Delft, so marine engineering. And then I started working for Boskalis, where I also did my thesis. And they asked me if I liked the work, if I wanted to stay. So I did first I did 5 years working for the offshore engineering department. And after that became a bit too theoretical. I did a transfer to the salvage department. So it's the previously known Smith Salvage. I think it's still called Smith Salvage, but it's part of the Boskalis group. And I did 3 years as a naval architect. So you join the teams as the they call it the rekenwonder, so the engineer who does all the calculations on the site.
Oh, okay.
And after that, I started the family. So it's a bit difficult to combine this international on the spot work with the family life. So I quit that and I started as a freelancer, and that's what I'm still doing.
Okay. Nice, quite interesting. We're going to come back to this because it's quite interesting about career progression, etc.
Yes.
But first, why did you work as a naval architect? Did you have any interest about the maritime world or like technical subjects?
Yes, well, I was always technical. I started with Legos, as I think most of us will do. But
Nice.
then, where this interest came from, we did have a small boat as a kid for a few years, which I always enjoyed. But I think the main interest came when I saw the story of the Kursk, the submarine that sunk, the Russian submarine. And I found this so interesting that I thought, wow, this will be my dream job if I can do this, do the engineering for this. And because it's so unique and so, you can put a lot of creativity in these kind of jobs. So that's what I thought, okay, let's see if I can do this. So that's how I ended up in the marine world. But also what helped is when I did the visits of universities, I found that in Delft, it's a very small group. You have marine engineering, which is only marine engineering. I think in when I started, there was only 50 students. So it's a very nice atmosphere. It's everybody knows each other, and it's a very friendly place to be. So this is what really appealed to me as well.
Yeah, and you did this quite famous university, Delft, if I'm correct.
Yes.
And there are many technical people there. And I know that in terms of if you are looking for technical young starter, this is the best university to look at because they have like very nice programs to start working in engineering, marine engineering, to become then naval architect, etc. But of course, we will come back about this topic. But first, Hans, I want to ask you about the specialties in naval architecture. Because, of course, we have different kind of naval architect. We have in the yachting industry, we have more related to ships, commercial ships. We have an offshore, maybe more like you. Can you explain a little bit all specialties and then talk about yours, of course?
Yes, yeah, as you start in Delft as well, I think it will be the same in any high school, is that you have different people, different interests. And we have two main groups in Delft, which was the hardcore engineering, so hydrodynamic, and then the other side was with design and also operating ships, so ship economics, but also shipbuilding. It's a completely different department. So construction, and then what I do more is operation, but it's not a specific subject in Delft as it was. It's more offshore engineering. It's there's in our department at Boskalis, there were actually I think only 2 marine engineers who studied in Delft, and the rest were mechanical engineers. And because it's well, if you have an engineering background, you can do a lot of different work. And as long as you have
Yeah.
a love for the job, you can learn anything later on as well. But it does help to have the marine background, absolutely.
In terms of specialties, if I have, for example, just finished my studies, what is the choice I have on the table?
There's plenty of choice. Well, I think you should explore what you like to do, because the main thing in your job is that you have a passion for it and that you enjoy going to your work. And for everybody, this is different. But if you don't like the dirty steel work and you like the economics and to work with ships and to make money with it, then that's a direction you can choose. But of course, you can also get your hands dirty and go on the shipyards or go in offshore oil and gas or, there's plenty of work to do. You can also maybe you can even become a captain. What I found out only after I started the studies is that there is plenty of work. They're always looking for good people with technical background. So if you finish the study, the whole world is laying at your feet. Yeah.
Great.
So even
Nice.
if you don't like the direction that you chose during your studies, you can always switch in your job, because usually it takes only a very little input from your side, as in re-education or a bit of studying, to focus on a different subject.
No, that's completely true. The maritime industry is quite versatile. You have many sub-domain, I can say. But to come back with your specialty as a project engineer or naval architect, first, what is your role? With oil, gas, renewables, because it's quite not common at all.
No, it's well, I think in my opinion, it's a very large business, but that's also because I'm focused in it. So I see a lot of work going in this sector. What we're doing mostly is we are preparing the offshore installation works. So at Boskalis, we were doing installation of onshore and offshore wind farms.
Okay.
And then mostly the foundations, because the wind turbines themselves are done by a different company. We were doing a lot of transports, so with barges and heavy transport ships. As Boskalis also took over the former Dockwise with the Vanguard. I'm sure you may know it. So you can imagine, you get this project, the Vanguard has to transport 100,000 ton of offshore platform. Okay, go and prepare this. And what kind of supports do you need? How far do you need to sink? Can you support it? Is the ship strong enough to support it? Then, of course, that is the main part. But then you also go into the operational part. So, okay, where do we need the tugs? How much bollard pull do you need to pull this thing to where it needs to go? So there's a lot of engineering, a lot of calculations that need to be done before the project can be executed. And this is your part as a naval architect. And as a naval architect, they mostly look at you for the marine part. So a large portion of my work as an engineer was to look at motions, ship motions. So let's say we have a cargo on a barge and it's sailing across the ocean. Okay, what are the acceleration on the cargo and what kind of CFAS do we need to make sure that it doesn't fall off?
That's very interesting. Yeah. So I imagine in terms of, we're going to come back after about technical knowledge.
Yeah.
But so your role, this is like the pre-conception of the project. Like making all the plan, the calculation.
Correct.
And then what are the next steps?
Well, in Boskalis, that was a part that I really enjoyed. Is okay, you prepare the entire project, you make all the calculations, you do all the predictions on how it's going to happen, and then when the project is actually going to be executed, they ask you to join this project. So you go offshore, you go on the ship, you go on the installation, and you guide the entire project team. And mostly they do this because if anything changes in the plan because of unforeseen business, that you can do the on-the-spot calculations. But also it helps you a lot to learn from the actual operation. Because what I've seen every time is that whatever you calculate, reality is going to be different.
Yeah.
But with this process, you learn a lot for your next projects. And of course, it's really awesome to be on. For example, I was on the Asian Hercules 3, which can lift 5,000 tons, and then you lift a foundation for a wind turbine of 90 meters high, and when you stand next to it, it's insane. It's really, really impressive.
Wow, I can imagine. And why
Yeah.
do you say like the reality can be different? I want to ask you why, because of the weather, because you always have some last minute change.
Well, to give you an example, we had with this Asian Hercules 3, we were doing installation for foundations of wind turbines off the coast of Aberdeen. And we had mooring lines set out, and these had to be really long because we didn't want to have uplift on the anchor. But what happened is that these steel wires were on the seabed, and because of a little bit current, there was sand coming over the steel wires. And you think you just pull it out, but over this, if you have a few hundred meters of cable in the sand, you get so much friction that we actually broke the wire just because of the wire twisting in the sand. And this is something we never could foresee.
That's insane. So yeah, that's something you cannot predict it can change all the plans. Yeah.
Yeah, exactly. Yeah. And then you are there. Oh, we broke a wire. Why? And then you see all this sand inside, and the wire is twisted completely until it broke. And then you need to find a solution on the spot because that's why you're there.
Yeah. That's insane. So I think this is the particularity, I would say, of offshore engineering, because in like conception of ships, like the everyone knows what is naval architect. People think is that the one responsible to create the ship. So you have less unpredictable stuff happening than like just the offshore industry, which is
of course
against the nature, against the wild, against the ocean.
Yeah, absolutely. In construction, of course, you find that some pieces are not fitting as you thought they would because of bending or whatnot. But this is a bit less than I think when you're offshore in an environment that is continuously changing. You have bad weather, you have sea conditions or the seabed conditions which are different. And you may have heard of a pile run that can happen. It is these wind turbines. They have the foundation is essentially a very long steel pipe.
Yes.
So what can happen is that this pipe is put into the seabed, but because the seabed is too soft, the pipe just slides in. Essentially. No, it goes straight down, but it keeps on going.
Oh, okay.
Yes.
Oh, okay. Wow.
Yeah.
So it's continue to. Oh, wow.
Yeah, and it goes incredibly fast because these pipes, they weigh, about 1,000 tons. But if the sand is not strong enough, it just sinks into the seabed and then it goes beyond where it needs to be for the installation. And then, you cannot recover because it's stuck in the seabed. And then you need to remove it and install somewhere else.
Wow. And I imagine to remove it can be quite complicated because you need, it's quite deep most of the time.
Yeah, no, you cannot pull it out. The only thing you can do is to cut it off above the seabed and then you remove the piece that is sticking out and you install a new one.
So you lost one big piece of your installation.
That's
Well, that's good to know because that's. Do you have some other stories like that about unpredictable scenarios when you have to? It's quite insane that people who want to work in this offshore industry cannot that they don't imagine the challenges we have.
It's crazy. One interesting story was that what we did before is with there was a wind turbine foundation, and a suction pile.
This is. Can you explain a little bit for the audience, maybe?
It's essentially if you put a bucket upside down on the sand under the water, and you pump out the water, then the bucket will be driven into the seabed because of the water pressure above. And many times they do this with 3 suction buckets, because then you can direct the heading and the orientation of the pile on top. But there was a trial done north of the Netherlands where they had one big bucket. And this bucket was, I think, correct me if I'm wrong, but I think it was 20 meters high and 18 meters in diameter.
Okay.
So you can imagine they can put it over your house and your house wouldn't be damaged. So it's really big. But they started to do the installation, the suction, and then they hit a layer of a little bit more harder sand. So they just kept pumping and pumping. until the pressure was gone. So what happened? This entire bucket just imploded.
Wow.
Yeah, but the problem then was it was damaged because the water got in because it was broken, and then you cannot pressurize it again to push it out.
Oh, so you lost it.
So it was half installed, and they cannot take it away. So they cannot put it in a wind turbine on top, and they cannot push it back further in. We were also asked to remove it, and then the option is just to dredge away all the sand around it, and then you can pull it out or lift it out, essentially. Yeah.
But the amount of sand you have, it's quite, it's not so realistic to
No,
to
there's
put it
a
away.
few options you can do. It's you can use an airlift, in which you have a very long pipe, and then you put in compressed air at the bottom, and of course the air will rise. But if the air rises, it takes the water with it, so you get a huge flow of water and air going up, and this takes away the sand also.
Wow. Okay. That's quite the proportion can be quite huge, I imagine.
Oh yes. Oh, it's insane. It's when you stand next to it, it's very impressive.
Wow. So that's why your role is quite important, because company can lose a big amount of money if they don't take into consideration all those. But about seatbelt, I mean, this is something you can predict. What kind of is it your role? Because it's more like related to environment,
Yes.
Yeah, biology, this kind of stuff.
Yeah, the seabed itself is for geotechnical engineers. So as soon as it goes into the sand, then it's out of your region of
Your scope, yeah.
what you can do with it. Yes, exactly. But working with sand as a dredger or a dredging company, they're working with sand continuously. But then you work together with an engineer for the geotechnical part.
Okay. Yes, you need to make collaborations.
Exactly. You never do a project alone. And also, all your work will be checked by a superior, because when you start, you have your studies, you have your theoretical knowledge, but it's quite good that they check what you calculate to do a reality check.
Yeah. You always need double check even. That's the key. What kind of calculation are important? What kind of terms? For example, you have resistance of materials. You have I don't know. You have many terms quite interesting in this industry.
Yeah, exactly. What I find a lot, what I use a lot is actually strength calculations. So because you're working with steel, and you need to know if it's strong enough. And of course, if it gets very complicated, you're going to do a FEM analysis. And if we need to do a FEM analysis, we have a separate structural department, which of course you can do as well. Then you become a structural engineer, and then you really focus on the steel works and how the forces are working. But for me, I'm mostly focused on the global picture. So I do global strength calculations, your statics and dynamics. And then if it gets too complicated, you forward it to a structural department.
Okay. To make this calculation, do we have like formulas, or it's like based on some software we take into consideration the history of the
No, for me, mostly I have some prepared Excel sheets or MATCAD calculations, which I can use. So you have the calculation, which you have done a few times before, you have it prepared, and you just change the values and you get your result. But a lot of times it's also based on your insight, and then you use your standard formulas to calculate the basic forces. Yep. So that's one part, and the second part is the motion analysis that I've done quite a lot. But this is, you only use software for that. So you calculate your stability. We used GHS and Hexalf, but there's Delft Chip. There's a lot of different software programs you can use. And then once you have your stability characteristics, you can go into the hydrodynamic characteristics. So you do the 3D diffraction or your motion analysis with the software. Not sure you're working with OrcaFlex or not.
No, I didn't.
Okay. Well, this is really nice program you input your RAOs. You know what they are?
No. Can you explain a little bit?
The RAOs are actually values which state how much your ship is reacting in certain sea states. So let's say you have beam waves of 1 meter high. What are the roll, pitch, and yaw characteristics?
Okay.
And what if you have head waves? So this will all be different, but these can be calculated by software, and then you can enter this into OrcaFlex. And OrcaFlex is a software in which you can model your ship, but also lines. So you can have a mooring line, or you can also have a load in a crane. And that the ship is moving in a sea state according to your RAOs. And then the load on the crane is starting to swing with the ship. And then you can see, okay, do I need to attach more lines to keep the load stable? Or will these lines break? Because if you go over a certain load, you know that the lines will break.
Yeah. Wow, that's interesting. On the accuracy of this software, is it like 100%, or you have still some...
It's quite accurate, especially in motion above water. If you get into slamming or very complicated motions in water, it's disputable, but mostly it's quite accurate. We even had videos of a load in a hook which was swinging, and we could reproduce that exact same motion in the software. So you can put them side by side, and you can actually see that you can remodulate the motions that you see in real life, which is really awesome to do.
This is awesome. So as soon as you have the right calculation, the software like display that everything is okay, it means that when you will like produce or build your project, you are quite confident about the result on the stability, how it will behave according to different scenarios. Okay.
Exactly. And also you have, of course, you calculate the maximum forces, and then you have a multiple of safety factors that you have to include to make sure that it definitely doesn't go wrong.
Okay. That's quite a powerful tool.
Exactly. For example, you can see the load in your lifting slings, and you can see the dynamic load as well. And you want to make sure that your lifting slings are not even loaded up to 50%, to make very sure that they will not break and your load is falling down.
Yeah, to have margins, no? I think.
Exactly. Yeah.
Oh, that's interesting, by the way, about margins. What are the kind of percentage of margins you need to take into account on the... Yeah, of course, it's always good to have big margins, but why sometimes we can't like have the highest margins possible? Of course, it has cost.
Yeah, exactly. Yeah, for steel, you have IASC, which you may know already. But for most marine operations, we use DNV guidelines because, of course, we cannot come up with these margins ourselves. So what we do is we use the guidelines, which are from DNV, which have a lot of experience in these operations, and they know what has been going wrong. And then if something goes wrong, they see, okay, where is this coming from? And then if needed, they adjust the safety margins. Also, if you prepare an offshore project, eventually it will have to be insured.
Yeah.
So there will be a marine warranty surveyor checking all your calculations, all your results, and only if they are happy, then you can insure your project.
Okay.
So, and they are also using the same guidelines, also the DNV guidelines, or maybe ABS, or whatever the project wants to use. So they use the same guidelines, and they check your calculations according to these guidelines. Have you used the same safety margins? And then that, if that is okay, then they approve it.
Okay, great. So it's good to know that you have like a standardization of these margins. It's not like we need to take this percentage. No, it's like clearly you have a certain amount you need to respect. Great. You have project engineer, naval architect. What is the difference between both? Because I know that you can be both, but what are the difference?
Mostly it's a name what they give to the animal that does a certain job within the company. But what I found is that a project engineer is preparing the project as I described before, then he's making the manuals, and then he's joining the project.
Okay.
As a naval architect, that was my official role when I worked for Smith Salvage. This is a completely different world.
Okay.
Because then essentially you're at home or in the office, you're doing maintenance work. But let's say there's a ship which is on fire. And then they send you to the airport. You go on a plane as quickly as possible. So let's say I was at home, I get a call, okay, there's a taxi for you in 2 hours,
Wow.
prepare your stuff. And then they fly you to, let's say, Sri Lanka or wherever. And then when you're on the plane, you try to get as much information from this ship as possible to try to make a stability model. Because once you get there, they're asking you, okay, is this ship going to sink?
Oh, wow.
How much water can we use to extinguish the fire before it will sink?
Okay.
Or if we put a lot of water in the bow, but not nowhere else, is it going to break?
Okay, interesting.
And exactly, then you have to give answers to these questions because they are very important.
But is it possible to analyze all this in 5 hours? I mean, you need what you need. You need like
Well, we in the end we got quite quick at making models, and also what we have is a support from other naval architects, which they can help you to make a model.
Yeah.
But usually within, let's say, 12 to 24 hours, you have a basic model running, which you can put the weights and the stability criteria. But this also depends on what kind of information that you get from the client.
Okay.
Of course.
Okay.
If you get a stability booklet, it helps a lot. If you get a lines plan, which is a bit rare, then it helps a lot in making the model. Yeah. But also we have a database of ships, which we can, let's say we have a tanker, then we have a tanker in the database with slightly different dimensions. So we can just scale it. And then we know, okay, we have an approximation of this ship, which we can use. So we can already make basic calculations.
Okay. You know, I didn't know about this incident part of on the role of naval architect. I thought it was more like he was taking care of the conception of the ship, like the pre-conception. But I didn't know that his expertise or her expertise can be useful during this kind of scenarios.
Yeah, no, absolutely. But then also you have a team that is going towards the casualty. But this team is very limited because they cannot put indefinite amounts of people on a plane. So you have usually one naval architect, and then the other people are a project manager, and then a foreman, a deck foreman, and a few riggers who actually have to do the work. So you are the only one who can do these calculations.
Wow.
So it's a bit of pressure, but it's also very exciting to go to these kind of jobs, of course.
Wow, that's quite insane. Yeah, it is.
Yeah. And this is one part of the salvage job. The other part is they call it wreck removal, and that is if a ship has already sunk and it needs to be removed, there's no big rush. Maybe you heard about the ship that collided with a bridge in America.
I did one video about it, by the way.
Exactly. Yeah. So this would be more of a wreck removal. You go there, there's no big rush, and you make a proper plan. You take your time to remove whatever you need to do. So the ship, I think in this case, the ship was not too badly damaged.
No, just the freight more. Yeah.
Exactly. Yeah.
Okay.
But this, okay, you can imagine there's no big rush. Let's do it a bit slower, but take your time.
But the good example is Costa Concordia, for example, because it was a unique scenario. It has been long time to organize everything, to age of the ship, on etc.
Yeah, exactly. So this, you have a lot of time, a lot of preparation, but then you also you transverse more into the project engineer role. So you actually have to make manuals. You have to do all the loops that you have to jump through. So it's more work, but it's also the projects are usually a lot more complicated.
Okay. In terms to come back with knowledge, you cannot learn everything at school. You need to learn on the field as well. Are you learning? With your experience, are you learning every day new stuff? And do you need to be proactive in your learning journey, or you can say, "Oh, I have the diploma, I'm good to go, and I don't have to learn more stuff."
No, the diploma is very nice to have, and absolutely it will give you a good start. But what I would suggest is make sure you get a job in which you go into the field and you see things in real life. But it doesn't have to be offshore. If you go on a shipyard, make sure you go on the ship. You see where the people are working, and you see the things much clearer when you have seen it in real life. Because of course you can imagine any kind of design, but then if you see it in real life, when you have been welding, actually, you know that welding upside down in a small corner under in the double bottom is really annoying. So if you can work with that, if you become a much better engineer or naval architect in the office later on. So also, if you go offshore, do projects, be on ships, then you get more of a feel for the actual engineer or the physics involved.
Okay. Yeah, it's yeah, of course,
Yeah.
of course. And in terms of evolution, ships will stay a ship. I mean, but some with this new environment rules, this new kind of technologies like fuels, like ammonia, hydrogen, it's add some complexity to the job. Maybe is that true?
Yeah, absolutely. Yeah, and in every sense, I think. Because if you have, let's say we transverse, what I heard is that if we want to sail electric, then you need the entire cargo space for battery. So until we find a completely different battery, this is not going to be anytime soon. What may happen is that we start to transverse to ammonia.
Yeah.
But then if you have an accident and this ammonia is starting to leak out, it's very dangerous.
The disaster. Yeah, it is.
Exactly. So this will bring with it a whole new set of rules and regulations that they need to comply with. But also, if things still go wrong, what can you do then? Yeah, but this is a continuous process of evolution, not only in development, but also in rules and how you design your ship.
For sure. Do you see that we have like this shortage of technical people in the maritime industry?
I think so. Looking at, well, I was a bit afraid to start to work as a freelancer, because you think you need to be at a company and then, you need people to give you jobs. As a freelancer, you are dependent on other companies to give you their trust and to give you work. So I was quite scared, to be honest, to start like this. But I would definitely not recommend it to do just after you come from school, because what is really important is that you know a lot of people. You know people to give you work. And once you've worked at a company for a while, you have a network of people that know you, that know that they can trust you with some kind of work, and then you can do whatever you want. But also right now, I'm working 100% remote. And that's a lot of people or a lot of companies don't really like it, because they like you to be in the office at least 2 or 3 days a week at a minimum. But then once you have established a certain kind of trust with a company, then they allow you more. And this is also because there is a shortage. Because if there's another naval architect available that they can ask to come to their office, this definitely has the preference.
Okay, yeah. No, I ask you this question.
So that goes to show that there is quite a shortage indeed.
Yes. Yeah, I ask you this question because I noticed that it's quite hard to find like technical people, especially the offshore industry, because it's a niche. So yes, that's quite interesting to know. I hope that new generation will just understand that technical working as a project engineer, for example, naval architect, it's very interesting, and we need people like that. We need it's a big plus in the industry. Can you explain maybe a little bit about career progression, how it works from scratch to the highest level?
It depends on your own ambitions, of course. As you start from your school, you start as a junior, and you're really learning the companies and the work that you're doing. And I have people I studied with who really wanted to go into management. They like to make progression in their salaries and in what they do. So they progressed from junior engineer, senior engineer, and then they went into engineering, a leadership role. And this is if you like this, of course you can do it. It's you go into management, and then you go into even higher management if you like, but then you won't be doing the calculations anymore. So if you like the calculations, you can decide, okay, I want to be just a really good engineer, and this you can do also for the rest of your life. And usually within a company, you can still make progression in your salary or in your work. You can also go to a different company where they have better conditions.
because we tend to say that it's good to start as technical, but at a certain point in your journey, you will have to switch to commercial because you will be limited in terms of salary, in terms of progression. Is that true, or you can still?
Yeah, it is true. I think what is mostly for engineers is that they love their work too much. They enjoy too much to do the calculations, so they don't mind the salary so much. They love what they do.
That's good.
And I did find that if you are available to go offshore, you can make a very big jump, much more than going into management.
Okay.
Because there's a shortage of people who are willing to go offshore. So you get quite a nice bonus in spending some time offshore. And especially when you're young, you don't have a family, please do. It's the best experience you have, and you make good money as well. So these are this is the best choice you can make, in my opinion. But of course, you must like this. If let's say you want to make a lot of money and you want to give up everything for that, okay, then you go into management. But what is more important? Is it money, or is it loving the job? Enjoying what you do every day.
That's true. I think it's this is maybe the 60-40% rules, or 80-20,
exactly.
depending the people.
Yeah, exactly. This is a choice you have to make for yourself. And it's what I find is actually going offshore and working in strange places where little other people want to go. Then that's a big jump that you can make.
That's good. I imagine.
Yeah, but it's not steady. So it's one job and then you go to the next one.
Yeah, I imagine. No routine in this kind of job.
Exactly. Yeah, it's if you want to settle down, then the management role is a lot more safe. But then, in my opinion, this is something that you would have to love to do.
Okay, great. Thank you, Hans, for all this knowledge. Insights. Do you want to add something? Maybe if you want to give advices for young people, or even for a starter in the industry, or even if you want to add something else, feel free.
It's a good one. I think you're already in the industry, because otherwise you wouldn't be listening to this podcast. And I think you made a very nice choice. One that I found later on only, that there's plenty of work to do. You can really do exactly what you love to do. And this is already a big bonus, which a luxury that a lot of people don't have, I think. If you're fed up with marine engineering, you can still go into other businesses, because there's always a shortage of technical people.
Yeah, that's true. But when you start in the maritime industry, I think 90% chance you stay, because it's like, it's not only an industry, it's like, that's, I don't know some people, when someone starts in the shipping industry, you always stay. This is a universal rules, I noticed. If you start, you will stay, because it's like a closed industry. You have your network, you have, everyone. Then it's, of course, you're smarter to stay, because you have so many benefits if you have so many experience in this industry, because, as you know, it's so technical. It's so, you cannot go on the street and ask someone about shipping. No one knows about shipping, but it's crucial. It's 90% of all goods around the world.
Yeah, absolutely. Oh yes, and that is shipping. But then
offshore
is a completely different world. Yeah. As I said, because the stories I tell you, you are completely surprised that this actually exists and this is happening. So if you start working in this business, there's so many amazing things that you can do.
Yeah.
And
it's
a good career that's ahead of you.
It is. Thank you, Hans. Thank you very much for this episode. Thank you for joining me today, and I wish you all the best.
Yeah, you're very welcome.
Thank you for listening and watching this episode. We are looking forward to bring you more insights from maritime professionals, experts, and students. Do not hesitate to follow the podcast on Apple Podcasts, Spotify, and YouTube. Your support means a lot to us and helps us to bring you more content.